There are different ways to apply chemistry to fabric. Regardless of the mechanical means used, it's important that the chemistry be applied in a uniform manner. The chemistry that is used with water or with a solvent is either solubilized, dispersed, or emulsified. In the most conventional method, the chemical is diluted in water, which is patted onto the fabric. Next, the fabric must dry, allowing the water to evaporate. Depending on which finishing chemicals are used, it may be necessary to apply higher temperature for cross-linking or curing. Let's take a closer look at the patters and what they do. Vertical patters are most commonly used. As the fabric moves through a series of rollers located in a trough, it is immersed in a bath containing the chemistry. By the time it comes out of the trough, the fabric has been thoroughly wet out. Then it is guided up through two round squeeze rolls. Called a mangle, these rolls squeeze together precisely with consistent pressure so that chemistry is uniformly applied to the fabric at the lowest practical wet pickup. A variation on this is the use of horizontal patters to apply chemistry. When the fabric leaves the trough, it moves vertically up between horizontally positioned rolls. As in vertical patting, the chemistry, the construction of the fabric, and the hardness and pressure of the roll determine how much water and chemistry is picked up by the fabric. An alternative to patting chemicals onto fabric is to spray. With this method, a liquid bath is pumped through spray nozzles onto both surfaces of a fabric as it moves along. You can choose to apply chemistry to only one side or both sides of the fabric. The object of the spray system is to achieve less wet pickup than what is achievable with patting. With lower wet pickup, the same amount of chemistry can be present, but less water is used. Less energy is needed to evaporate water, and energy consumption is reduced. Another system, called kiss roll, also applies chemistry gently without pressure. With this method, the fabric rides just above a container where a roll turns in a bath, picks up the chemistry in the trough, and carries it to the top to kiss the surface of the fabric. This is normally a one-sided application, but two units can be oriented so chemistry is applied to both sides of the fabric. In fact, each side can receive a different chemistry. The engraved roll system is similar to the kiss roll technique. In this case, an engraved roll, with lines or cavities etched in its surface, is placed partially in a chemical bath. As the engraved roll picks up the chemistry and turns out of the bath, a blade, called a doctor knife, works as a squeegee to wipe the excess off, leaving chemistry only in the etchings. The fabric moves between the engraved roll and a squeeze roll, and some pressure is applied. The application of chemistry must be very precise because the fabric never goes into a bath. With this technique, you can get very low wet pickups of water and chemistry. Another system for applying low levels of chemistry, or to only one side of fabric, is called the knife-over roll. This takes advantage of thickened chemistry or foam placed in a crevice under a doctor knife. As the fabric moves under it, chemistry is spread along the fabric, which then moves through two final squeeze rolls. Coatings are often applied with this type system. Why use foam? Foam is a collection of many small bubbles. The chemistry is around the outside, while inside is air. When foam is used instead of a bath, very little water is needed, and there is less wet pickup. Another way to apply foam is on a horizontal roll patter. In this configuration, stable foam rests in the crotch of the rollers. As the fabric is pulled straight down through the foam and then the two squeeze rolls, the pressure collapses the foam. Stable foam needs this pressure to burst the bubbles that hold the chemistry. Alternately, unstable foam, with bubbles that pop on contact with fabric, can be used in systems designed without a mechanism for applying pressure. The surface contact with the foam is sufficient to collapse the bubbles that contain the chemistry.